Hi everyone, welcome to the lecture on group velocity and phase velocity. Let us start with this concept with one simple example. Let us assume that we are standing in one point and watching the cars crossing that point. If I take the speed of one particular car, then that I can correlate with the phase velocity. Instead, I take speed of all the cars into account and find the average and give as a result. Then I can compare with the group velocity. So what I conclude here is the speed of individual car I can correlate with the phase velocity. Right? Similarly, average speed of cars I can correlate with the group velocity. Now we go to our concept. So phase velocity and group velocity I am going to define in the context of waveguide application, right? Because we are going to use these two terms in waveguides in our subject. So what is group velocity is that it is a velocity with which a wave is propagating through a medium. That is known as group velocity. Whereas phase velocity is a velocity with which the wave phase changes in terms of guided wavelength. So it's a simple and direct definition of a group velocity and phase velocity, right? So now I take one simple example again from some other subject called modulation, right? We know that AM wave, it will be looking like this, right? And in that we draw AM wave like this. So red color is representing carrier and black, sorry, red is envelope or message, whereas black is a carrier, right? Here message is a envelope and it contains more components, so it will travel with what you call as group velocity, whereas carrier is a single component, so it will travel with the phase velocity. So simply if any wave travels, the envelope here nothing but our message, envelope travels with the group velocity vg, whereas carrier is traveling with the phase velocity vp. And one more point I want to emphasize is mostly vp is greater than vg, especially in waveguide context. Phase velocity is always greater than group velocity. Why? Let us take the same car example. Here we know that some cars will travel with high speed, some cars travel with low speed, and some cars traveling with that average speed. So whenever we take average, cars are having different high value than average speed, or they will travel somewhat lesser than average speed also. So mostly in waveguide context, the individual component, that is Vp, is always greater than Vg, right? That we must keep in our mind. Let us prove that why it is always greater in the next slide. Okay. Now we take different conditions and see what will happen. Case 1 is when Vp is greater than Vg, that is phase velocity is greater than Vg. So who is traveling with the phase, right? So the component waves are traveling with what you call Vg is group is nothing but our envelope, whereas Vp is a component, right? Right. So when Vp is greater than Vg, the component waves moves faster than envelope, because Vg is a envelope velocity. And when Vg is greater than Vp, then component waves move slower than envelope. Next, Vg is equal to Vp. That means both groups, envelope and components are traveling with the same velocity. They are moving as a single component, right? When Vg is 0, that means envelope is stationary, because envelope is traveling with Vg. So Vg 0 means the envelope is not moving, that is Vg envelope is stationary, but Vp is not 0, that is a condition. So that means a component always propagating, whereas Vp 0 means the envelope is moving but component is stationary. Next, so this is a formula which is used in waveguide. The phase velocity Vp is equal to V naught divided by root of 1 minus lambda by lambda c whole square, right? And Vg is equal to V naught root of 1 minus lambda by lambda c whole square, right? Here Vp is a phase velocity, Vg is a group velocity, and V naught is a velocity in free space, that is 3 into 10 power 8. Lambda c is a cutoff wavelength. Cutoff wavelength is a maximum wavelength a wave can possess when it propagates through a medium, or here our waveguide. If the wavelength of the wave which is propagating through a waveguide is greater than cutoff wavelength, then the wave will not propagate through waveguide. So cutoff wavelength is a maximum wavelength that your wave can possess. Clear? Now we see. Let us take. So what is the thing? Whenever our wave should propagate through a waveguide, the wavelength should be less than cutoff wavelength lambda c. So when lambda is less than lambda c, lambda by lambda c is less than 1. When lambda by lambda c is less than 1, if you apply that here, what will happen? Vp will be greater than V naught, because 1 minus some small number, it will become a fraction. Square root of fraction, again it will be fraction, right? So 1 by fraction, that will be a big number. So Vp is always greater than V naught. Same thing you apply when you divide a number by fraction, the result will be higher than the number. But when you multiply any number by fraction, the result will be less than that number. So Vg is less than V naught. Yes. So apply the same thing. So what we are understanding from this? So whenever a wave is propagating through a waveguide, Vp must be greater than V naught and Vg less than V naught. So Vp must be greater than V naught, whereas Vg must be less than V naught. So from this we understand Vp is greater than Vg. Clear? So phase velocity is always greater than Vg, that is Vg is less than Vp. That's what I told in the second slide. Clear? Simply, next case, if lambda is greater than lambda c, that is your wavelength of the wave propagating through a waveguide is greater than lambda c, means what will happen? Lambda by lambda c is greater than 1. Clear? Because numerator is greater than denominator. So lambda by lambda c is greater than 1 means what will happen? It is 1 minus big number, so it will become imaginary. That means Vp becomes imaginary. Similarly, Vg also becomes imaginary. That means the wave cannot propagate. So whenever you want the wave to be propagated through a waveguide, the wavelength of the wave should be less than cutoff wavelength. I hope you understand what is group velocity and phase velocity. If you have any doubt, you can clarify.